W number 2, or chemical world number 2, we are going to be defining evaporation. We're going to carry out an evaporation experiment, define what rock salt is, describe how to separate rock salt, define what we know to be distillation, explain what a distillate is, and have a look at a distillation experiment. So, you go to the beach and you go down to the sea and you take a bucket of salty water. How are you going to get the salt and the water separate? Now, in this case, we need to remember that salt dissolves in the water, so it's soluble in water. So this is the solution. So solution is made up of a solute, which is the salt, and the solvent, which is the water, to form a solution. We can use a method called evaporation. Now, and again, guys, this is something you have done or can do at home. If you have a solution of salty water, if you heat up the solution, you can cause the water to begin to boil at 100 degrees Celsius, and it starts to evaporate. So it's changing state. So you're going from a liquid to a gas or a vapor. Now, there is a disadvantage here. What do you think that could be? In this case, what would happen is we'd actually lose the water. We would be able to retain the salt in the evaporation basin, but all the water would be evaporating off, which, you know, if you're aiming to collect water, is not a good idea. So what is rock salt? It's salt, sand, and soil. So miners, when we go and we buy our salt in the shops, if we think back to the very beginning of where that came from, it actually came as rock salt. So miners would actually have to mine rock salt. What they use rock salt for is, you know, gritting during the winter time. They put it on our roads to help prevent a buildup of ice and freezing. So we're going to have a look today at separating a mixture of sand and salt. So if we've sand and salt in a container, we are going to have a look at how to separate that. Now this is just a very simple setup that you could actually do at home. Please don't. So we're going to talk you through that. So you take your sample of sand and water, and the first thing I would recommend you do is, in this case, it's sand and salt. The first thing I'd recommend you do is you'd add some water. What is the benefit of adding the water? Well, the benefit of adding the water is so you can dissolve the salt that is in the sand. So you make a solution of salt and water, but also you have an insoluble solid in the solution, which is the sand. So the first thing, as you can see here, guys, I'm just going to fast forward it a little bit, is you would add your water into your sand salt solution, mix it, give it a good shake so the solution is homogeneous, and we know the word homogeneous means the same throughout, so the salt is evenly dispersed in the water. Give it a good shake there to dissolve it, make sure it's homogeneous, and then you would put it through your filter paper. So we've looked at making fluted filter paper before, just going through that again. So we flute the filter paper, pop it into the funnel, and we would pass it through the filter paper. Now what you'll see is the residue remaining on the filter paper, and the filtrate, which is the salty water coming through into an evaporating basin. We can now separate our salt from our water. We have our sand separated from our salt, but now we want to separate our salt from our water. So here we go, guys. All we do is very quickly set it up. Tripod, gauze, and this is a little propane burner. It's an alternative to a Bunsen. You guys will never need to use one of these, but it's just to show the experiment at home. Now, as you can see here, over time, the water will begin to boil and evaporate off. So as you can see, the evaporation, and if you look very closely at the sides of the evaporation basin, there is the crystals of salt remaining behind. And that's the perfect method for separating a solution of sand and salt. So number one, we would make a solution by adding in the water. The water is to dissolve the salt and filter it through, remove the insoluble solid, which is the sand. And then we would undergo a process called evaporation to remove the water from the salt. So first thing you do is you make your solution, you filter it, so you use the method of filtration as seen here, and then you use the method of evaporation. Note in this case on the right hand side I have a little jar of water, or beaker of water underneath the evaporation basin. It's just to ensure that the evaporating basin doesn't get too hot and the water evaporates off quite easily that way. The next thing is, we've already discussed what would happen is if you wanted to keep your water. Well, we'd have to use a different method, and we use a method of distillation. It is the vaporizing of a liquid by boiling it and then condense it. So you're changing it from a liquid to a gas, and then you're going back from a gas to a liquid by cooling it. So Justus von Liebig was one of the founders of organic chemistry, and he came up with this most amazing idea and piece of equipment called a Liebig condenser. This is it here. If you go on and do leave insert chemistry, an awful lot of the organic chemistry experiments are based around this piece of apparatus. It's fantastic. So this is the setup that we would use if we wanted to separate a mixture of salt and water, but also keep the water. So first thing we do is we would set this piece of equipment up. Now, normally what you would have is 2 clamp stands, but they're not shown here just to make your life easier to visualize it. So water is pumped in through the outside of the Liebig condenser from the bottom, and it is pumped back out at the top. So you would place into this pear-shaped flask, you would place the water salt mixture. We use anti-bumping chips. These are used to keep a boil quite steady and not boiling over. As you can see, our Bunsen with an open collar, so we have a blue flame. This would heat the solution in the pear-shaped flask. This would vaporize, so it goes from liquid to gas and it moves up. Okay, and then it starts to come down the tube, the glass tube. Now, the steam enters here at the condenser. What we'll note is the condenser obviously has a surrounding tube that is quite cold, so it condenses the liquid of the gas back into a liquid. And it is contained here in a conical flask, and it's called the distillate. So this would be distilled water, which is pure. That means there's no other substances in it. So the distillate, the definition, will be purified liquid that is the product of a distillation. So guys, that's everything in our next step in separating mixtures. We've talked about evaporation. We've looked at an evaporation experiment. We've talked about rock salt and where it's used. And we've looked at an experiment how to separate rock salt. We've looked at the idea behind distillation and how to do it. And we've defined the word distillate. So if you have any questions on this, please just get in contact and let me know.